All right, good afternoon, everyone. Hoping everybody's really refreshed after the break. This is the last session, so you must be feeling a little bit tired, but congratulate you on choosing the right session for those tired people that want some excitement. There should be no shortage of excitement here over the next 90 minutes. So thank you for coming along. My name is Stefano Freguia. I'm an associate professor at the University of Melbourne, and I'm the co-chair of this session on urine separation for a circular economy of nutrients, something that has not been touched much in the rest of the conference, but it's something that we have been working on for a long time, and more people are actually looking at with some interest. So we'll try to take a little bit of a deep dive into this. But before, first and foremost, I'd like to acknowledge the traditional owners of this land, the Jagera and Turrbal people, for the city of Brisbane, and particularly would like to acknowledge the role that the traditional owners had for 60,000 years on managing the land, the water, the nutrients, and the environment of this country. So here's what you can expect from today's, where do I point it? Is the green one. Okay, from today's session. Well, we're stuck here, but so we start with some introduction. You see a lot of chairs here. There are a lot of panelists, and I'll start by introducing the actual chair. I'm a co-chair, and the chair of the session is Aprilia Vellacott. She's a principal process engineer and technical director wastewater for Australia and New Zealand at Jacobs. So welcome, Aprilia. I hand it over to Aprilia for the introduction of the rest of the panel before we move on to the session.
Thank you, Stefano, and welcome everyone. Just to complete things, I'll introduce Stefano. So, I don't think you mentioned everything, did you? So Stefano's an associate professor in chemical engineering, and his research is unlocking wastewater's resource recovery potential. And he's also the deputy director of the ARCNES Hub about nutrients in a circular economy. Okay, are the other panelists going to come up and join, please? So we have Ho Kyung Chon, University of Technology, Sydney. So Sean is a professor in the School of Civil and Environmental Engineering and the director of the ARCNES Hub. Thank you, Sean. Next we have Matthew Mullis from Urban Utilities, business process specialist in the customer and innovation team, focused on developing innovation opportunities, and Matthew is an ARCNES Hub partner investigator. Next, Syed Iftikhar from Griffith University. Syed is an associate professor and applied environmental economist with experience in policy advice. Bernadette Mackay, next, from the University of Southern Queensland, professor and director at Centre of Agricultural Engineering, focused on circular agro-industry approaches for bioenergy and biofertiliser. Nicole Robinson, Nicole's from the University of Queensland. Nicole is a research fellow in agriculture and food sustainability focused on optimising crop nutrition through plant-soil microbe interactions. And lastly, Johannes Yamaka from Tampere University. Johannes is a senior lecturer in environmental engineering. His research focuses on electrochemical methods for nutrient recycling. If I can welcome all the panellists to the... I'll now pass to Sean to give an overview of the hub.
Good afternoon, everybody. So I'm very happy to share our research hub, which we call ARC Industry Hub for NICE. NICE means Nutrient in a Circular Economy. So we have worked together for the last 3 years, and I'm happy to share our progress. This NICE project will be a key partnership to transform the wastewater industry, build confidence for a market in reusing wastewater and urine as a source of fertilizer for agriculture, horticulture, and parkland. To achieve these goals, we have worked together with 7 universities, 20 industry partners, also 3 international organizations. So main objectives are how to effectively collect and then develop the process to convert urine to fertilizer, and how to optimize our fertilizer, and finally the application with the end user, golf courses, some of our parklands, and we also like to investigate economics. So we have a lot of people are working on this economic side, and then public engagement, public also communication, perception. So we have developed for the last 3 years. So these are the university, 7, also 20 industry partners. So we have Matthew here, industry partner, urban utilities. Also we have some of the industry organizations, Southeast Water, Melbourne Water, and also technology development, Origin Water, and some of the Parkway. So we all together to look at our same goal, how to make a better collection of this urine to convert to fertilizer. Also we have a collaboration with the IWA and UNIST and Ditch Earth Institute, who are leading the organization of the urine diversion systems. So this is the one of the examples. So we have 3 nodes: Sydney, Melbourne, and Brisbane. So every CI with the partner investigator try to develop their own target for their developing this urine to fertilizer solution. And this is the Sydney node. So our university has 12-story building with urine diversion system. So we collect around 1,000 liters of the urine from our university students, and then we look at how to convert this urine with membrane bioreactor. So we like to remove the virus, PFAS, also micropollutant, antimicrobial materials. So we can remove the most of them, and then try to convert to our fertilizer. Ovar is the urine is valuable, so we try to make a good fertilizer and tested some of the vegetables. So that's the current status of the Sydney node. So we are looking at how we can get the approval from the New South Wales EPA and then make a commercialization. So that's the progress of the Sydney node. So Brisbane node, so this is the Stefano. He's working on U-Gold system. So urine is gold. So you can see his technology, microbial electroconcentration. So hydrourine goes to the cationic membrane. So we can extract ammonia, potassium. Also we have a cathode, and we have an anionic membrane to recover phosphorus, and we can collect a lot of high concentration of fertilizer. So they have tested together with the urban utility. So you can see their technology, and then if we have a technical tour on Thursday, you can visit this facility. And this is the Melbourne node. Also, we're working together with the Melbourne CI, Stefano and myself, and together with the Southeast Water. So we tried to make a mobile system with a trailer system. So we have a solar-driven energy and then male and female toilet, and we just collect only urine, and we can utilize our membrane bioreactor, and we can have just a direct application near around the parkland. So that's what we have done so far. So everything is progressing well, and then we will have a more commercial opportunity next year. So if you are interested, then please visit us, and we're happy to show you much more progress. Also, we like to expand our technology for different nutrient-rich wastewater, like industrial, urban wastewater, also piggery wastewater, livestock wastewater, and we have anaerobic digestate. So there are a lot of nutrients, so we can collect and then process our wastewater to fertilizer and apply for the low quality application like a tough glass or some animal crops, also parkland, tough farm. So that's what we have done for last 3 years. Thank you.
All right, so that was it in terms of slides. So now we are going to change format. So later there's going to be a discussion, and you're welcome to intercept and ask questions about this concept. But now first I'd like to test your knowledge of urine. Everyone urinates and does that multiple times a day, but how well do you know your urine? And that's really what I want to know. And so we're going to test that. Many people talked to me yesterday during drinks saying that they started working on urine. That's mostly researchers. But I'm also wondering, how well they know the stuff. So what we're going to do is you're going to whip out your phones or devices, and best thing is to scan the QR code. And if you fail with that, you can just put in the website polf.com/espreguia. The first two things that pop up, you just press skip so that you don't need to enter any information. And then when everybody is ready, we'll get going. You actually might take a peek at the first questions cheekily.
So we can souvenir.
Yes, so for the ones that will thrive in the quiz, there's some prizes. I don't show the prizes yet, but it's something you can look forward to. So, surprise. Don't leave the room, you're not allowed to leave the room at this stage. All right, so did anyone have trouble? I can help you, otherwise we get going. Let's fire up. So the 7 questions. First, so we start a little bit lightly with the fun fact. Urine was a valuable commodity in ancient Rome because it had good properties as a laundry detergent. There were actually places dedicated to this where all the urine was put in tubs, and women would actually step in and just rub the urine on the clothing, and this would nicely remove stains. Well, Romans did that and more. But Romans did not drink coffee, and nowadays we do drink a lot of coffee, and coffee is responsible for some of the toughest stains that our clothes can endure. And some of you dressing white would know that if that happens, it's going to be a tough time if you don't get quickly to the stain. So the question is, on a scale 1 to 5, how good do you think hydrolyzed urine, which is the one that has converted urea to ammonia, so it's rich in free ammonia, how good do you think it is at removing coffee and soy sauce stain? Well, actually, just say coffee. Soy sauce was not part of it. So 1 being poor, 5 being excellent. So let's see what you're saying. give you about 30 seconds to think about it, and this will go for every question. And then when I say stop, you don't change your answer anymore. You can change by binning your answer and changing it. But we can see, 37, 38% think excellent, 34, you guys are changing too much. You're gonna give you 5 more seconds. 5, 4, 3, 2, 1, and you're not allowed to cheat. At the end, when I ask you, you got all the questions right, you're not allowed to cheat. And this is probably the toughest of all questions, because we want to give rewards, the prizes to honest people. So, okay. So, what's the right answer? We actually did some tests. So there was a shirt, and there was a pretty heavy coffee stain over there. The pointer will be this thing on the left, or on the right?
Just down.
Oh, down. Yeah, so this was the coffee stain. So then what I did, I sprayed some concentrated hydrolyzed urine on one section only. And you can see that there was some action. It was a smearing of the stain. So something was happening. Water alone didn't do anything. So there is something there. But then after rinsing with water, it all looks the same. So outcome, poor. It was 1 out of 5. So I can see only 10% now are competing, are still competing. So we're not trying to say that urine is good at everything. But this is just for coffee. So if tonight any of you experience issue at the gala dinner with sauce, oil, or other things, you can come forward and we'll be able to treat you on the spot during the dinner. So just a couple of sprays and a rub, and we can see whether the tomato sauce can be effectively removed with our special detergent. All right, so next question is the use of urine as fertilizer. So the Romans, again, at the forefront of utilizing this special fluid, thought it was good as a fertilizer, and they use it for pomegranate. And also, peeing on the lemon tree is good for it, says the Australian old wife tale. I don't know if that's in the US too, peeing on the lemon tree. No, a version of it. So there's common understanding that urine is good as a fertilizer, but is it good for trust tomatoes? And also, can you apply it as such, or does it need to be diluted? So the question is, how many times do we need to dilute it? So anticipating that it should be diluted to work well for growing nice and healthy trust tomatoes. So off you go. You got 30 seconds, not that hard, and then there's going to be a sharp cutoff. And if you want to join, you just have to scan the QR code in the top right corner, and you can compete. But because you've missed the first out of 7 questions, you will probably not get the prize. But okay, so we're a bit all over the place. 54% of you are sitting on 20 times, but don't feel peer pressure. 5, 4, 3, 2, 1. Stop changing your answers now. The correct answer is 4 times diluted is good. You can see that was obviously a lot of the stuff I'm showing today is not science, is more anecdotal and maybe the result of one try. So we're just having fun here. But when you're applying in large amount undiluted, the plant doesn't grow. Why? Well, there could be reasons related to salt, related to nutrient shock. You dilute it 4 times, applied at the right rate, the plant grew nicely, and then the tomatoes came up, and I invited Sean over for dinner. All right, so 2 out of 7. I think you're not doing so well, which is encouraging. I thought maybe it's too easy, but yeah. This is an easy one. How much salt is there in hydrolyzed urine, which is the same as urine, really? When you compare to seawater, so 2 times as salty, same 1/10, 1/100th. So how salty is your urine? And that changes, of course, if you overhydrate yourself, but on average. This is an average. Go. Whoa. We don't know who's answering what, so don't be afraid. We'll ask you at the end how many you got right. Alright, so a lot of changes, but we're gonna cut off here. 5, 4, 3, 2, 1. And most people got it right. Well done. So urine ranges 2.5 to 4 grams per liter of sodium chloride, thanks to Vera that has measured it for years. Whereas seawater is typically 35, so 10 times saltier. And that salt could have to do with failure of the trust tomato growth when you put the urine as such. But there could be other factors there. All right, almost halfway through. The next question. Oh, this is a fun one. Urine as a disinfectant. Actually, the Romans, I'm not sure they knew this, but actually we kind of discovered this thanks to one of my PhD students, Chen, who's in the room. So there's alleged, but actually there's this paper from 1968 that proposed this. So alleged antimicrobial properties of urine. However, we find that hydrolyzed urine is not very good at killing bacteria, but if we concentrate it, it becomes good. How many times do we need to concentrate urine so that it becomes an effective antimicrobial? So can we just pee on our wound, or would that not do much? So off you go. Jen, you can't answer this one. All right, so let's cut it off in 5 seconds. 5, 4, 3, 2, 1. Well done again. Half of the people got it right. So these are RO membranes that were exposed. Chen, you can stand up and take the credit. Exposed to hydrolyzed urine at different concentration. So you can see that, yeah, this is biofilm growth. We don't need to demonstrate that. So 1.5 concentration, 2.5, still pretty dirty, and 4 times clean slate. So that's the concentrate side of an RO membrane, and no bacteria, no biofilm growing. When that concentration is overcome. Reason here is the free ammonia, and there's a threshold beyond which most bacteria don't like living. Next one, you're doing very well, I think. You're just really picking up. Oh, PFAS. PFAS are forever chemicals, right? Everyone knows. Urine is laden with all sorts of chemicals, pharmaceuticals, but what about PFAS? So now I give you 4 fluids. Rank them in order of increasing PFAS concentration. Likely, I would say. Assuming they all come from the same location. Somebody living and drinking water in the location, not traveling is allowed. Blood, urine, tap water, and sewage. Go. So this will show a little bit differently. It will show where people, how people rank them. Not allowed to use the internet. This one is really hard, so I give you a good 20 seconds. 20 seconds. Okay, finalize your answer, and 5, 4, 3, 2, 1. People say tap water. Wait, but tap water, urine, blood, wastewater. I don't know how to read this one. But well, remember what your answer was, but the correct answer surely is blood is the by far most concentrated, because PFAS, they just love your red blood cells, and they are just by a large margin concentrated in your blood. So the only way to actually reject your PFAS is to donate blood. So just consider that. Urine is actually the least concentrated because PFAS, they just filtered well, but the kidneys don't really get there so much. And tap water is what we drink, and one of the sources of our PFAS. We bioaccumulate them. Sewage is tap water that has been further contaminated. So although it's the same range, it's a little bit more concentrated. So the rank is urine, tap water, sewage, and blood. Next. Only 2 left. Okay, importance of urine in urban wastewater. True or false? Urine contributes 80% of total nitrogen and phosphorus concentrations in sewage. If you attended some of the talks yesterday, you would know this in 2 seconds. So this one is going to be really quick. I only give you 10 seconds. 5, 4, 3, 2, 1, and here's the cutoff. Whoa, whoa, whoa. Don't change your answer, and bang. So it's almost an even split in the room. False, because it applies only to nitrogen, 80%, but phosphorus 50%, because phosphorus likes feces as well. So, well, that was a bit of a tricky one. But let me give you more information. Sulfur 70% in urine, where no alum is used, because otherwise there's a bunch more sulfate. Potassium, average 65%. The flow, depending where you live, could be 0.5% or 1%. Okay, the last one. Urine diverting toilets. We're going to collect the urine. We need to use some of these. Rank these modern, state-of-the-art urine separating systems from lowest to highest flush volume. So we have a Uridan urinal, a Caroma urinal, a Laufen toilet, and a Worstman toilet. So you can see some of the mechanisms there. Pretty tricky, but you see the blue stuff is water. So which one uses more or less water? This is pretty hard one, because you actually, if you don't work in this field, but the advantage of using water, the system, you save water. So flush water is 20% of our home water consumption. So if we implement this, well, there's water saving, but we know that. That's why we have a lot of waterless urinals in airports and shopping centers. Okay, so I'll let you think. There is a tricky thing in there, like 2 of them are exactly the same water consumption, so it doesn't matter which one you put first. All right, so pick your ranking and we will close it in 10 seconds. So from lowest to highest. 5, 4, 3, 2, 1. Good job. The first 2 are waterless urinals, so they don't use water for flushing. The Worstman uses 300 milliliters per flush. So, and then it creates a water lock that blocks odors from coming back and avoids scaling and blockages in that section of the pipe. And the Laufen, they sell it as entirely waterless, but in reality you need 65 milliliters in your main flush going down this path to just push out the urine so it doesn't block that U-tube and avoids odors coming back. So this is how they manage. In terms of odors, this one uses this device where you pee, this opens up and allows urine to fall through, and then the two sheets stick together again, preventing odors from coming back up. And this one uses an oil. So you pee into an oil and the oil just creates a seal. All right, I'd say well done. And how did you go? Who got them all right? Who got 6 out of 7? Who got 5 out of 7? Yes. William.
I didn't know about the coffee statement. I never got
But we had 5 out of 7, that means you got at least another one wrong.
I did.
Yeah. Okay, 4 out of 7. 3 out of 7? You can't. Alright, so we got these beautiful towels sponsored by the ARC Hub for Nutrients in the Circular Economy. They have the nice logo there, and they're quite nice and multi-use. So I think there were 3 of you. So thank you for participating, and this is for you. And then there was good job. Yeah. And shame on everyone else for you. You? Okay. So just properly bring it to the cantina tonight for the third one. No, they're not. But I think it did well, and so this shows us how we don't really think about the stuff so much, and there's a lot of fun facts related to it. So let's see what comes up when I press next. Oh, perceived barriers towards implementation of a circular economy of nutrients based on urine separation. So this, stick to the same QR code. If you lost it, simply just rescan it. And this is a word cloud. Just, we want to know what you think. Put in a single word, or if you want multiple words, you need to put a dash in between them. Otherwise, it separates them as two separate entries. So just have a thought, and want to see what comes up here. And after that, these guys are going to reflect on some of the things that are popping up here. So make it hard, then we can have more fun. If you see one that you like, you can retype it so that it gets bigger. So things are changing, a few are coming up as prominent, so take a look at what's there, and it's the last chance to put in another one or put in one of the same ones that you like. You can put in as many as you like, but we're going to cut it off in 10 seconds now. All right. I don't need to count down, but if you stop, then I can actually read it without feeling seasick. Yeah, cost, infrastructure, yeah, we got some issues there. Perception, public acceptance are highly related to each other. Regulations is popping up. Safety, maintenance, accumulation, law, which is going towards regulation. End use, value, technology, transport, sewage, economics, order. All right, so are you guys ready? All right, so let's just remember some of these. Conveyance, we can come back to this as well, but we're gonna actually move to the next slide now. And we're going to start a discussion with our panelists. Panel discussion, which will be run by Aprilia. During the panel, feel free to put in any questions that you like, anonymously, so that you don't get caught. Or you can also raise your hand. We're happy to be intercepted and divert from the theme. In fact, we haven't fully prepared them, so we want to have a little bit of fun, just really challenging this panel. Okay, over to you, Aprilia.
Well, thanks, Stefano. I hope you all enjoyed that and learned something. I definitely did. So we might start talking about toilets, actually. So Johannes, you're from Europe, the birthplace of urine diverting toilets. Could you tell us a little bit about them and challenges and acceptance of them?
Oh yes, certainly. So my name is Johannes and I am from Europe, maybe the only one here, Stefano is also. And the question was about the history of urine diverting toilets, and I think that the history is not from Europe. I mean, they come from dry toilets, and that was kind of also what the traditional landowners here had. So for millennia we've been living on dry toilets, and I think the urine diversion system, at least in the literature, has evolved a bit from that. So at least in Scandinavia, where I come from, these dry toilets and cabin toilets, and these are very common and still in use every day, and it's nothing out of the ordinary. And also using of this compost from dry toilets is there. And I think that's where the idea of using the urine diversion has come from. There's a Finnish saying, exactly like you guys had, that don't pee on your neighbor's garden. And somebody might think that it's because it's rude, but actually the saying is because don't waste your pee on the neighbor's yard, use it on our own yard. So the compost from those dry toilets has been valuable, and I think from that the urine diversion has become, and I think the first mentions in the literature are then from these kind of eco-villages that started using nutrient streams, and in Sweden especially. Sweden has been a forerunner, so in the 1980s, 1990s there started to be these kind of eco-villages. Actually, there is one in Australia quite close here in Currumbin, and in 2007 they also installed these kind of urine diversion toilets. And I think that the idea was that it would then kind of start moving more mainstream, and there was a big hopes for that. Another place where it's being common is Switzerland. I don't know about the history in cultural sense, but at least publication-wise, they have been big prominent pushing on this. And then there was a lot of this kind of eco-sanitation movement. I don't know if anyone of you has heard about it, but it was trying to use this urine diversion and dry toilets for developing countries, making sanitation more healthy and easy, and also using this. But the fertilizer aspect wasn't as prominent. But I think from these it has then gone into mainstream, and the literature has been a lot about the fertilizer use and urine treatment. And in 2010s then we started to have more advanced urine diverting toilets, and I think that has also opened up the fact that we can get the urine in a way that is sustainable, and the things actually work, and people are managing to use them.
Yeah. Noting one of the concerns that came up, or queries, was around conveyance. Is it used more like locally where it's collected, or do you convey it for collection and treatment further away?
So historically, I think these have been used on the farm, on the site. And for instance, my parents have a summer cabin which have a dry toilet, and we use the things that we compost there on the site, and that's how it's been used. So I don't think there has been any conveying, except for before modern times when we had dry toilets in cities. That has been a big thing, that you take the the black, what is called night soil, that is, outside of the city. And actually, fun fact, one of the first railways ever built in Europe is from Marseille to the countryside to convey night soil into the countryside for fertilizer use. So I think that it's been very, very accepted, and it's only a modern phenomenon that we kind of have diverted, and it's become a taboo. And when you look at the queries that they are made about social acceptance, I think that Nordic countries are one of the top ones. Germany also, and then Switzerland and other Middle European countries where it is not considered weird.
And the technical issues with the toilets and their operation have been resolved. They work well now.
I think you have to ask the specific case, but we have technologies where we can run. And I think the easiest place to see is that when you visit any public space in Europe, and most likely here also, but I don't know, is that waterless urinals in men's rooms are everywhere. It's common, and there is no problem with that. It doesn't have all the technical things that we need for the urine treatment, but basically about the blockages and odor, those problems can be solved.
Yeah. Okay. Matthew, is this something that you're saying Australian Water Authority is interested in being involved in urine diversion? Oh, yeah.
Is this?
Why do you?
Yeah, so certainly, as we've just learned, urine is a major component of sewage, contributing 80% of the nitrogen and 50% of the P. So that obviously has a big driver for our wastewater treatment scale and intensity. And so in our current paradigm, we are transporting urine we're diluting it in water, we're transporting it to a treatment plant, and then we're getting the nutrients out again. And I think in the number of sort of challenges that we have going forward with population growth and densification and constrained land, we're going to have to start doing more with less. And so when we think of urine in terms of its impact on wastewater treatment plants, in terms of nutrient removal capacity, energy consumption, and ultimately those nutrients discharged to the environment, we are interested in having a variety of options available to us. Obviously there's a lot of interest in intensification and side stream treatment. I see urine diversion as something that could sit alongside as complementary to that, and delivering, I guess, rather than an end of pipe solution, let's say, it's more of a starting to address the causes and drivers of our capital investment program as we're looking to support growth.
And what type of buildings do you think it could, as a first step, you could look to install urine diversion system in?
Yeah, so I mentioned densification at the top. I think we need to go where the people are, shall we say. Ideally, I'd say we're looking at large new urban buildings and precincts, so apartments, offices, entertainment precincts, transport hubs, airports, wherever you have lots of people congregating regularly, to be able to maximise the return on investment on the additional infrastructure that you need to collect, store, and treat and transport the product.
Okay.
So location is also important. So ideally be situated closer to processing centres or end use areas such as green space. In urban areas is going to be increasingly important. Green walls, urban agriculture, those sorts of end uses that may come online in the future once we resolve some of those health and safety kind of concerns and build confidence in the market.
Yeah, public acceptance, sure. Thank you. Right, great to see some questions coming in. Just picking one there, not sure who on the panel's best, but to answer. So who's doing urine diversion well? Sean, is that something yeah.
So, yeah, we are doing very well. As I presented. Also, there are 3 different case studies. First one is the Richards Institute in the US. So they just small village, eco village, and then they utilized all the resident area and the people to donate their urine and collect in the decentralized system. And simply they utilized a very cost-effective technology, which is the 80 degree, just pass through the urine for almost 18 seconds, and then all the virus are just killed, and then just to utilize as it is. So that's the US case. They are trying to utilize this system. Also in Paris, the OGAP program. So they have like a 2,000 residential, one small precinct, and then they just renovate all the urine toilet with the Laufen. Already the Stefano showed the Laufen toilet system each home, and then they collect the urine selectively, and just utilized developed by IWA. They have simple like a biological treatment, fluidized the system, sequencing batch reactor, and go through the next step. And they have all the ammonia nitrate ballast fertilizer and apply to the wheat, like some of the food, and they create the biscuit. I have a biscuit and taste it very much similar to original wheat biscuit. Also, we have a lot of application, large scale of the chemical process from Swedish people. They utilize calcium hydroxide to collect some of calcium phosphate and dry using the natural wind, and have a little bit of high temperature and the powder type of the fertilizer, and they try with this system. Also, biologically membrane bioreactor electrochemical process in our ARC Nice Hub. We look at the more building level as well as the mobile toilet trailer system. So that's how we can represent general urine diversion system and application.
Good, sorry, it's hard to keep up with all the questions as they're coming in. So what are the challenges in upgrading the existing infrastructure to source and separate your own collection infrastructure? Matthew again, or Stefano? Yep.
I'm happy to comment on that one.
Yep.
So I think it's important to note that in most cases, probably as a starting point, we do have a lot of existing buildings in Australia, and probably in most cases, it's going to be pretty expensive to retrofit. So when I made my other comments, I mentioned new buildings where you have that opportunity to embed the infrastructure from the beginning and to set up all of the systems. It's just too cost prohibitive otherwise to be able to make such dramatic changes to buildings. Although there might be some old Queenslanders houses that may be up on stilts or something that you might be able to retrofit for a home sort of system if that's legal, becomes legal. And what's the other part? So it's really all about, to me, it's largely in your big bottleneck would be in the buildings where people are going to be using, but there are also other potential markets that might be a little bit more agile. So there's a little startup in the USA called Wasted, targeting the Portaloo market for construction sites and festivals, and they a bit more mobile, like the Nice Loo down in Melbourne, and being able to access more flexible access urine sources more flexibly and convert that into fertilizer. So there's potentially a couple of different models.
Very interesting, thank you. Stefano?
No, may I add, yes, we're not looking at trying to recover all of it. That would be really too hard. But we demonstrated that if we could get 5% of the urine in the catchment, in some cases it's probably not that difficult. If we look at high use places, then the positive effects on the wastewater treatment plants would be massive. So you will regain capacity, you will be able to use that volume and those aerators to treat more wastewater from increasing populations. So that's going to be really helpful from a point of view of water utility. So in terms of the infrastructure, the last place to go to is to individual houses, because then you'll need to rely on curbside collection, and that would be really expensive. That addresses another question that popped up there. if you're trying to do it house by house, then you need trucks to pick it up, and that you know, again, we did some economics, would completely just swallow the cost. And so what we want is to try find some high-use toilets, shopping centers and airports. That's what we want to get to. Obviously, those are urban areas, and for regional areas, it would be a little bit of a different model with something like public toilet near buildings in the area where most people work.
So do you think Uber could have an Uber We or Uber Nutrients service?
Yes, drivers could stop by and collect jars and bring it to our depot. We are looking at literally every model. In Vermont, we have a collaborator, Abram, who's actually trialed this, a jerry can approach for a whole community. People are incentivized with in some forms. In Australia, we would give them Coles vouchers or coffee vouchers. You give us 100 liters of urine and you get a coffee or something like that. But actually it worked quite well. So to make a difference here for treatment plants, we need to get to that few percent urine from the catchment, and then we have made a difference.
Just a 10-second comment on not homes or households. The Sanitations 360 is a small company from Uppsala who are developing these things, and they have a unit that you can just install in your home in place of your home toilet, and the plumbing is exactly the same. Everything goes back, but it has a separate urine container, and it dries it into a pellet, and it incentivizes that you can actually use it in your own home for your plants or on your back garden. So this could be another option where you don't have to have a centralized treatment.
That's prone to misuse, though. If you're collecting all of that fertilizer and you chuck it on your garden, it's gonna find its way back to the waterway, which is not exactly what we want.
What do we do with this? I will just chuck it down the toilet. Cleaning up. Anyway, my chair's changed slightly to hear from a couple more people on the panel. Bernadette, your work's around sustainable agriculture. What type of farming is likely to accept the use of urine-derived fertilisers in the future?
So if we look at the type of fertiliser first of all, it's liquid fertiliser obviously, and so that already I guess cuts away from the broadacre farming, which is reliant on solid fertiliser. Also in terms of liquid fertiliser, it is more amenable to crops that seedlings which require a quick hit of nutrients. So if you are looking at very much the liquid fertiliser market, then you're in terms of the urban agriculture, turf farms are something that come to mind obviously because they're high utilisation of liquid fertilisers. The other aspect that we could look at is obviously the seedlings and the horticulture. So they're the two main areas for low-hanging fruit. Into the future, it will probably lend itself well to vertical farming. So vertical farming is horizontal trays of growth of crops stacked vertically, and they are in controlled environment agricultural CEA. So it's very much refined in terms of lighting, but it's also been shown that urine-based fertilisers are quite efficient in a soilless setting. So that's hydroponics in the vertical farming. The main drawback, however, is that it's got to be very much refined in terms of nutrient delivery to vertical farming. But I see that into the future, that is definitely an area I think that would suit itself well to, particularly in terms of location, peri-urban ag. If we look, and I'm just sort of thinking very much, probably not so much light years ahead, but it's on that same realm. It's around how it might actually be seen in terms of recycling nutrients beyond the earth, but also, you know, in environments like, say, in space exploration. I say that because we do, within my centre, we have work with large companies, Axiom Space and NASA, working with them to automate growth of food on the ISS. So if you think about, okay, recycling of astronaut urine, if we get over to that stage, then obviously that could be a nutrient source for actually fertilising crops, because, you know, they're looking at space exploration from Moon to Mars. That would require food for astronauts. So I just put it out there that perhaps that could be something very much into the future.
Thanks, Belinda. And Nicole, so you're an expert in nutrient uptake of in plants. What type of crops may grow well with your own fertilisers?
Oh, I guess this is following on from Bernadette's comments there. Those crops that are moderately receptive to salty conditions. So, and if we link that with the hydroponic situation, so there have been some studies showing good responses from things like spinach. Also, if we go a bit larger into things like melons and cucumbers, they've showed some positive response to this sort of nutrient composition that's offered by the urine-derived fertilisers. So here we're looking at giving sort of the nitrogen component in there and balancing that with the other maybe salt that's coming along with it as well. And they also tend, from the urine-derived fertilisers, to be a bit lower in phosphorus as well compared to maybe the other liquid fertilisers. So there's opportunities to supplement with other things, but maybe those that don't need as large a phosphorus load as well.
Okay, thank you. Moving back to the panel, the audience questions. There's one on the, so there's a 2.6 million metric tonnes a year urea production plant to be completed in 2026 in Western Australia. So what would, the question is, what would you think this could, how would you think this could affect the government stance on urine diversion? Does anyone on the panel know much about that plant?
Well, I can probably try to say something here. So urea is needed as a fertilizer. We import most of it. So building a large plant that supplies urea provides a source of the fertilizer, nitrogen fertilizer, on domestic soil, which protects Australia from geopolitical issues, and so that is something that can be done today, and that's what the government wants to do. In the long run, this could be replaced by urine-based fertilizers. So at the moment, urine contains 20% of the nitrogen that would be needed on soils. We will never get there, but certainly, just like 5% can help with water treatment plant, 5-10% could help urban farming, for example, and therefore reduce the requirements of making energy-intensive urea, because that urea is about 2% of the global carbon footprint, as well as similar fraction of the energy consumption. So as long as we have energy, we can always make urea and nitrogen fertilizers. But if we have an opportunity to move towards net zero, then urine can help on that front too. And let's not forget that phosphorus you cannot make, and there is phosphorus in urine. And so if we are concerned about the fact that phosphorus is running out, then we should save all our urine. And with talks about biosolids being incinerated, the phosphorus there might not be readily available, but certainly we need to look there as well. We need to recover as much phosphorus as we can, and doing it through urine is a rather simple way, because after we are looking at ash, we're going to need to do all sorts of treatment. So there's a couple of key points here. Phosphorus is one of them.
I'd just like to add to that. I mean, it's in response, obviously, to reduce. I mean, Intertech Pivot closed Gibson Island, so they're going to have to get urea somewhere else. So I don't, as you say, Stefano, that there will always be production of synthetic urea, but with hopefully more pressure in reducing emissions. Australian agriculture will have to go toward alternate, organic fertilisers to reduce emissions.
Thank you. I'm now going to say, so you're the economist in the panel. Will the circular economy make economic sense? And what are the hidden costs that might stop it, or the hidden values that might promote it?
Yeah, I think eventually it will make sense, but we have to recognize that this is a broader socio-technical and economic system, part of it. So we have to, there are multiple things has to align together. For example, like we have consumers, like general population, and their willingness to accept this kind of technologies or the products out of it. And then the service providers, which are both private and public service providers, like what is their financial gain or what is their motive to do that. It has to be beneficial to the environment as well, otherwise it will not make much sense of implementing these technologies. And finally, we have the regulators. They are driven by their own agenda, which could be guided by the international treaties or sustainable development goals or long-term aspirations. So all these three or four factors, when they combine or kind of work together, then we have an example of, or a good example of implementation of these kind of technologies and working together. So, but one of the challenge I would identify, and this is in relation to the hidden cost, is that actually there's limited number of information studies which looked at comprehensively the cost and benefits of the systems, of implementing the systems. There are many studies which have looked into the technical feasibility. Some have looked at in a very limited scale, like what is the cost of doing these technologies. But there are only few examples where they looked at rolling out, like in implementation, or even at the cost benefit analysis and a demonstration of the demonstration projects. So there is limited information in that aspect. So that's where we probably need to spend a bit more effort and our resources to understand it more. Thank you.
Back to some of the audience questions. There's one here. So if the NEAS process is incorporated salt removal and or considered salt accumulation in soils?
Yeah, we consider this sodium because sodium is definitely, we have to toxicity to the plant, and we try to look at how to remove this one, and the problem is very costly. The sodium is a very small molecule similar to ammonia and nitrate, so that removing this sodium is also removing all the ammonia and nitrate. So separation selectively sodium in urine we can do, but very high cost, which means we cannot do this kind of circular economy cost-effective process recycling urine. So we cannot put a lot of money to make a fertilizer. So we look at even though sodium is a more tolerant plant, because we are not talking about initially vegetable or a lot of food. So we look at more about sodium tolerant plants, such as some animal like crops, like a fat crop, like horses, they like the fat crop, with cow, tough glass, or some of the lawn. We can try it also golf courses. There are many gardening. So we like to look at this kind of application, which is also soil accumulation. In fact, soil accumulation will be less problematic than the hydroponics. The hydroponic has water, it keeps circulating, and you keep accumulating fertilizer. So inside our fertilizer, there are many different also components like organic, some of the also different salt, which is not the fertilizer, so plant cannot absorb. So I'm sure that only hydroponic, when you continuously utilize as a urine fertilizer, sodium accumulation would be problem. Otherwise, soil, the salt, sodium, it's a very small molecule, relatively easy to go penetrate and reaching out to the ground or underground water. So that's what we have target to apply in our fertilizer. So sodium, it's very costly to remove this one. So we are targeting which it doesn't really affect sodium toxicity for our plant. So we want to apply this fertilizer. Yeah. Thanks.
Yeah, I think that's a concern, and it depends on the context. So there's salt associated with other products that we apply to land, such as sea salt. And so you just have to look at what you're trying to deliver to the plants and when, in what volumes and at what concentrations, both in the hydroponics and also in soil. So there have been some studies over the long term, I think in Denmark, where they've been applying over 11 years different recycled fertiliser products, and a urine-derived one was one of the products, and compared to other things like cattle slurry and over that period of time, they didn't find any detrimental effects of salt on the yields of, in that case, was spring oats. So it is very dependent on the type of soil and the particular crop and the hydrology. So I think it's something everyone's aware of, and so it can be appropriately managed if it's monitored in the appropriate way.
Okay, thank you. Change topic slightly, talk about regulation, with the difficulties we have at times with the regulators and applying sewage-based products to soil. Stefano, is that something you can comment on?
Yes, I'm the expert in Australia of dealing with regulators on urine separation, so I can share our story. So we're actually looking at 3 levels of regulation, but 2 are easy and 1 is hard. So there's public health. The health departments have not expressed great concern. There is the EPAs, or equivalently environment departments that will be looking at environmental health risks associated with using fertilizers that are derived from urine. There's processes in place, and they're quite thorough, but as we found no real resistance there. I mean, biosolids are already placed on land, and biosolids are a lot worse than urine after our processes, which remove the majority of the micropollutants. So, so we're confident that there's no issue there. What we've found a little bit harder is working through the Plumbing and Drainage Act. So when it comes to installing these different toilets, well, in Australia we have, and I believe it's the same in many other countries, but there's an act that has been created over 100 years ago to protect public health. And this is attached to a regulation that is used to ensure that these practices are followed. So that states that no one is allowed to connect the back of a toilet to anything else than a sewer, unless this is a chemical toilet or a dry toilet, composting toilets in a national park, for example. So we are dealing with that. We discovered that when we were planning NICE. That was already like 3 or 4 years ago. And we proposed this, and the plumbers said, we're not touching this, we're gonna lose our license. So then we did a little bit of work, and we realized, yeah, this is a big issue, and they have to follow this protocol. So we need to actually work on an amendment of the regulation. So we embarked on that journey over 2 years ago. We're having regular meetings with the relevant regulator, which is the Department of Energy, Public Works and Housing here in Queensland, where we aim to have one of the trials. And we had endless meetings and conversations, and this ultimately led to a draft, which took almost 2 years, and the draft was to be approved by the relevant minister. So it actually reached the minister's office, which was in that case Minister for Energy, Hydrogen and Public Works. So the minister, eventually looked at it and said, okay, but in Australia we have this system where we have governors that are representing the king, and they have to countersign all acts and amendments. And so now it's stuck at governor, and the governor said, well, we have an election coming, so we don't want to be, left with this responsibility. So wait for the election. Now the election has occurred, and there was a government change. and so we are still stuck there. It sounds like a silly thing, but it's something we really need to get done, because these acts are created to protect public health, but we have all the tools in place to keep public health protected, and we value wastewater as a resource. The resource can be at the end of the pipe, or even better at the source, but we'll need to do it carefully. And we were smart. We involved the regulator from the very start, and now 2 years later, we're not done yet. So at least hopefully by the end of NICE, we've got something. So that draft is there. So we will probably be the first in the world to actually have managed to change the laws so that we can recover urine at the back of the toilet. But this is a pretty long journey. So if you're trying to do it, get on it early.
Very good. Johannes, is there similar issues in Europe?
No, I think the legislation is quite different. We have had several installations in my university and many universities I know, and we haven't had similar things. I think the laws or requirements that we get in no time compared to Stefano's case.
Yeah. Okay. Oh, that's good to hear. Sorry, question. Yeah.
I was wondering, is that Queensland only?
So yeah, every state. So there is the Climate and Drainage Act at federal level, which feeds into the different acts at state level. But the way they are managed, so in Victoria you can have an exemption, and there's a form. So if you have a certified plumber signing on the form, and then it's submitted, and it's not so problematic. So Queensland particularly has been the tough state.
Okay, interesting. Could urine diversion reduce the cost to customer? Another question from the audience.
That's a very important question, and why we're involved in ARC NICE Hub to help us understand the economics of urine diversion as it affects the whole system. So from housing, from collection, and ultimately it comes down to, does the economic value of taking it out of the conventional sewer system and taking it on a different pathway justify is the value justified by is the effort justified the value? And so one of the ways, but I suppose looking at the fundamental engineering and science of the matter, where urine being one major component of sewage, which then drives the capacity requirements at the treatment plant and the work and the technology selection there, and the effluent quality targets of the receiving environment set by the state government. It's in a way it's kind of simple, but actually doing that analysis is probably not. And so yeah, it's probably one of the areas that as I said, we have the least knowledge about in terms of the overall economics, but certainly from this multitude of life cycle assessments and other research that points to the environmental benefits of urine diversion and reuse of the product in terms of the life cycle greenhouse gas emissions and the eutrophication risk, because the nutrients just have no chance. Well, if properly managed, are not going to get into the waterways. So there's certainly strong, I'd say there's a logical case, there's a physical engineering case being a key driver, and there's an environmental case. I think the economics and technology and public health that new system looks like is what we need to uncover. And then for a wastewater utility, how do we, if this is something that we decide is valuable for us, how are we going to influence all the stakeholders so we'd be beyond our, perhaps beyond our traditional area of operation. We have jurisdiction up to the metre of the premises, and we have jurisdiction over the sewer networks as well. So we sort of be pushing some of the work upstream to the developers, and there's a question there: how can we incentivise them to uptake and get on board with the program? So once you start pulling a little thread, it's sort of lots of other threads start appearing, and you go, well, what about this and what about that? So really grateful for the NICE Hub for looking at a holistic approach to the question.
Yeah, very good. So looking at another one of the questions, probably the question is the key to start small? I guess it probably is. Start small, quantify the benefits, assess them, and progress from there.
Yeah, I think so. And yes, I mentioned some of the startups. There's I think the Rich Earth Institute, one that Stefano mentioned around Ava in the USA, who visited us last year at the NICE Hub Summit, noted that the environmental regulator in, I think, an adjacent county had was interested in pursuing a urine diversion strategy to mitigate the effects of septic systems discharging into the bay, and so we're seeing, this could be a game changer, but certainly it's got the attention of the regulator in terms of we need a solution. This is the only thing that we can do in this spot that might help accelerate, raise awareness of the benefits, and that's probably an area where urine diversion has been used in small communities as well. So. But to get the attention of a regulator as a solution to an environmental problem, that's pretty cool.
Very good. Another question here is, what are the challenges in upgrading the existing infrastructure to source separated urine collection infrastructure? Is that we covered that, did we? Okay. Just go through so we don't want to miss any of the questions. So why is urine diversion not common? It's not something we often talk about in industry in Australia when creating plans for the future. Maybe the wrong panel to be asking us if you're talking about it all the time, I guess. Well, so alternatively, the question, are you getting the message out? This is a good...
That's exactly it. We just need to pilot it, demonstrate it. And what we are trying to do is we're trying to work hard to Southeast Water, one of our partners, to actually pick up a catchment and take 5% of the urine out of this catchment, demonstrate the impacts on the local treatment plant, and process that urine into fertilizer and test it for growth locally. So then we just use that study and we go to every conference in the world and present that case study, and hopefully after that we'll see a few more people in the room showing interest in this, because obviously now it's so far-fetched that almost no practitioner would be interested in hearing this. So we need that step, and we are trying everything we can to get that first step in. We've done a lot of science, a lot of lab work. We got a couple of pilots built. We're stuck with regulators, but we need that first practical step, demonstrating you can collect it, can get that 5% out. The 5% makes a big difference, improves the performance of the local treatment plant. You can collect enough, you can use it, and the people are happy about it. So there's a lot going on there. So it's going to be a few more years, but hopefully we get that done, and that will be the trigger.
Just to comment on the barriers and incentives that we've been talking about here, and the environmental community, we have, at least I've been talking about fertilizers and in nature, environment and circulation, but that doesn't bring money, and I think one of the big barriers is the investment and getting money into it. And in this conference, for instance, people have been talking a lot about the greenhouse gas emissions in the sewage network and in the sewage treatment plant. And I think that's one of the things that we could use as incentivize, and we forget about the pressure on the fertilizers, and we could talk about just money. and greenhouse gases, about the incentives there. And another one that we talk about back home, but I haven't heard it mentioned here, is the infrastructure costs. So having a sewage system, especially in a new area, it entails a big cost, but then when you have a city, you have to maintain it. And back home we have this term called like investment debt or infrastructure debt or sewage debt, which means that we have calculated that we should be using X money every year to keep it in shape, and if we don't, it means that we are kind of falling in debt, and we have to use that money later, and it's going to be with interest. So if we are looking at a new area, or then an area where a big investment in the sewage network has to be done, we could look at that money and then say that, hey, let's do a decentralized system, at least partially, and we save X amount, 10 million or 50 million here, and suddenly the game can change, and those could be used as incentives.
And you bring up a good comment. I've got 3 questions on N2O emissions to finish off the last 10 minutes. So, interested in the potential impact of reducing N2O emissions as a minimum. You'd assume it would be equivalent to the nitrogen diverted, potentially even more when we look at different loads. Also the potential benefit or risk of N2O emissions from the fertiliser use, and if that's a difference, and maybe Bernadette, if you'd like to, you seem to be nodding, and then
Yeah, I think I was looking at that question first around the how does it compare to the cost of fertilisers. Well, if you're doing a parity like liquid fertiliser, which you can pick up from Bunnings or something like that, then it's hard to compare because the cost is greater, but then also it's about the different liquid fertilisers. They all contain a multitude of different nutrients as well, so it's hard to compare that one. But to your point, if it's about incentivising, and that's where I pointed to emissions reduction, it's about reducing NOx from wastewater treatment plants, but more importantly, avoiding any emissions from the production of synthetic fertilisers is going to be a big one. So if we're looking at, from an ESG point of view, for companies producing fertilisers, if they were to have a label on their product to say, and it has to be not greenwashing, if it's carbon neutral or whatever in terms of life cycle analysis, well then that will mean that there might be increasing pressure for companies to actually utilise that fertiliser.
Any particular points on interim emissions from the use of the fertiliser? Is that something that's been looked at?
I'm not aware of any specific studies on urine, but I don't think we would expect it to be greater than urea fertiliser if it's not combined with like a higher organic load or other things that you would expect, and so I think they would probably be lower or similar.
Okay, and the production or the treatment of the urine, are there risks to N2O emissions from the treatment processes?
Depends what treatment you choose. So we're now looking at maybe 10 to 20 different technologies, all at early research stage. Well, Sean and I are piloting too, and the outcome will be quite different. In our case, electrodialysis based, we're not oxidizing anything, so just transferring and concentrating. So there's no N2O being produced there. If you want to stabilize the urine by doing partial nitrification so that you neutralize the pH and reduce the odor, that's what Sean does. There is a potential there for N2O, but well managed. You've looked at it minimal. So okay.
I'm going to wrap up. There's so many questions to ask. One last question. Would the chemical, medical compounds and micropollutants present in urine be a concern to reuse in a fertiliser?
That's a good question. We don't really know, and therefore we need to remove them. So it's possible that when you spread the fertilizer of a large land, that the amount of micropollutants is not really an issue. The same for heavy metals and biosolids. But we can't take that risk. Also, antibiotics might create antimicrobial resistance and genes. So our technologies are designed to target those. So every technology is a different method, but we found when we use ion exchange membranes that 99.9% of any pharmaceuticals is rejected. So it's not present in our product.
Very good. Well, I'd like to thank everyone, but I'd like to ask Stefano to come up and thank everyone. And firstly, thank you, Stefano, for organising it all. And you can wrap up, please.
Yes, so thanking the whole panel for their time. These are really busy people, both in academia and practice. So we are sticking to Sudhir's dream of having a balanced academia and practice contribution. So it's a little bit tilted towards academia, as you might expect for something that many would perceive as so blue sky. But we do have industry here, and the next time we're hoping to be 50-50. So, but yeah, thanks to all of you. You did a lot of work. You joined meetings and took the precious time out of your daily schedules to prepare for this. So let's join me in thanking all the panels for their contribution. And thanks to all of you for choosing this session. And I hope you really enjoy it, and you go out and tonight talk to your neighbors at the gala dinner about what we discussed today, so that they also can hear about it. All right. So I hope, yeah, it's right on time. So there's nothing else coming up today except for the gala dinner. If you're in it, I'll see you there at 6:30. If you're going to a management committee as advertised today, just shoot upstairs now. And otherwise, just go to the pub and stay dry.
And you know what to do if somebody spills sauce on you in the garden?
Oh yes, yeah, come to us.
Keep it there.